Physics Part 98. When external forces act, the conservation principle does not apply. We need to consider a system in which no external forces act. Such a system is true lump of modeling clay and the earth. While the clay falls towards the floor, gravitational attraction will also pull the earth towards the clay. Conservation of momentum can be applied in that the total momentum of clay and earth remains constant throughout the process. Before the collision and after it, the effects of the transfer of the clay's momentum to the earth are not noticeable due to the difference in mass of the two objects. Example: a billiard ball A moves with a speed UA directly towards a similar ball B which is at rest. The collision is perfectly elastic. What are the speed VA and VB after the collision? It is convenient to take the direction from left to right as the direction of the positive momentum. If the mass of a billiard ball is m, the total momentum of the system before the collision is MUA. By the principle of conservation momentum, the total momentum after the collision is the same as that before, or MUA is equal to MVA plus MVB. The collision is perfectly elastic, so the total kinetic energy before the collision is the same as the afterwards, or half MUA square is equal to half MVA square plus half MVB square. Solving these equations gives VA is equal to 0 and VB is equal to UA. That is, ball A comes to a complete standstill and the ball B moves off with the same speed as that with which the ball A struck it. Another solution is possible algebraically. VA is equal to HA and VB is equal to 0. Thus corresponds a non-collision. Ball A is still moving with its initial speed and the ball B is still at rest. In cases where algebra gives us two possible solutions, we need to decide which is the one that is physically appropriate. Now it's your turn. A trolley A moves with a speed UA towards a trolley B of equal mass which is at rest. The trolleys stick together and move off as one with a speed VAB. A, find VAB. B, what fraction of the initial kinetic energy of trolley A is converted into other form in this inelastic collision? Well, I've got a section summary for you. The linear momentum of P of a body is the product of its mass and its velocity, described by P is equal to mv. Momentum has units kilogram ms or Newton per second. It is a vector quantity. Newton's laws of motion can be stated in terms of momentum. First law, the momentum of a particle remains constant unless an external force acts on the particle P, which is equal to constant. Second law, the resultant force acting on a body is equal to the rate of change of its momentum. F is equal to delta P divided by delta T. Third law, when two bodies exert action and reaction forces on each other, their changes of momentum are equal and opposite. The principle of conservation of momentum states that the total momentum of an isolated system is constant. An isolated system is one on which no external force acts.